Number 53 asks us to complete a table for ordered pair solutions for the equation y equals 3x plus 10 for different x values, the different x values of both -2, 0, and 2. So it already gives us what x values we should plug in to figure out what y values would create ordered pair solutions for this equation. So what I'm going to do first is set up some sort of table to make it organized so I can see exactly what I'm doing. So I'm going to start off with x, since I'm given x values, then 3x plus 10, because that is what I'm plugging my x values into. That answer will give me y. And then I'm going to get my xy pairs, ordered pairs there, because the next part says graph each ordered pair on the graph paper. So what I did on the right side of the screen is I've already drawn up some sort of graph. I went on my x-axis by 1s and on my y-axis by 2s. Now, my x values they give us are -2, 0, and 2. So I'm going to separate this out so it's nice and clean for us to read, nice and organized. So it's going to be 3, -2, plus 10. I'm going to go down and do this whole column here. 3 plug in 0 for x plus 10. So I'm plugging whatever x value into this x here. So 3 times 2 plus 10. So now I'm going to go back 3 times a -2. It's a -6 plus 10 is +4. So my final xy pair there is -2, 4. So it's going to be, I'm going to be looking at this first and this third column to find out what my xy pairs should be. So this 3 times 0, anything times 0 is 0, plus 10 is 10. So my coordinate point here is 0, 10. And for 2, 3 times 2 is 6, plus 10 is 16. 16 will go in that third column, so it's going to be 2, 16. Now I'm going to take what I know from this fourth column here, and I'm going to take those 3 points and graph it over here. So my first point's a -2, 4. It's right there. 0, 10. And 2, 16. I'm going to connect those points, put arrows on both sides because there are an infinite amount of solutions here. We're just given 3 different x values to work with. So we could find a bunch more points if we really wanted to, but they've only asked us for 3. Now 54 says find the common difference in the arithmetic sequence 126, 115, 104, or 104, excuse me. So I'm going to find out 126 getting to 115. So what I'm going to do over here is do 126 minus 115. See if I can find a pattern. And that ends up being 11. So I know to get from 126 to 115, you have to subtract 11. Now I'm going to make sure that's correct by going 115 minus 104. And I end up, again, getting 11. So I know it's subtracting 11. So right there, that tells me my answer. So the common difference, which is normally written as D equals, the common difference is -11, or D equals -11. Either one of those is right. The common difference is -11, as long as we got to that point there. Now, on 55, it says find the next 3 terms in the arithmetic sequence 54, 43, 32. So again, first I have to find the common difference here. So to get from 54 to 43, I'm subtracting 11. 43 to 32, subtracting 11. So I have 54, 43, 32, and it says find the next 3. So I'm going to put just 3 little blank marks here so I can fill in that for us. So 54 to 43, I subtract 11. 43 to 32, I subtract 11. So to get from 32 to the next, I'd have to subtract 11, and that ends up being 21. 21 to my next one, subtract 11 from 21, I get a +10. And then subtracting 11 from 10 is -1. So my final answer, 21, 10, -1. Those are the next 3 terms in this arithmetic sequence, this specific arithmetic sequence here. So 56 says find a function that describes the arithmetic sequence 15, 16, 17, 18. Use y to identify each term in the sequence and n to identify each term's position. So this term here, that's position 1, 2, 3, 4. So I know my function should be y equals, that's what every function starts off with. So n is the location the number is in its sequence. So it always has to have something and plus or minus something. Okay. So we're going to try and fill in this by saying, let's see, what is 1n? So we're going to always start with this 1n. So I'm just going to write 1n or just n. Either one's going to work. So 1n there for n, since that's the position, that's 15. So y is equal 15. So 1 plus what equals 15? In this case, plus 14. So we would have 1 y equals n plus 14. Now we have to make sure that works, because it might work for one term, it might not work for the next. So let's look at, if n is 2, plug in 2 there, y equals 2 plus 14. 2 plus 14, 16. And these numbers actually should equal y. So when n is 1, y should equal 15. When n is 2, y should equal 16. When n is 3, y should equal 17, and so on and so forth. So we're proving that that actually works. So our final answer should be y equals n plus 14. Now, for 57, it says find the 12th term in the following sequence: 4, 13, 22, 31. So since we're finding the 12th term, we want to use our formula that we learned, and I had you guys write a bunch of times. It's a little n, a sub n, equals a sub 1 plus n minus 1 times d. Now remember, n is the location that number is in that sequence, and d is the common difference. So of course we have to first, let's find the common difference. That's always the easiest for us to do. So to get from 4 to 13, I add 9. To get from 13 to 22, I add 9. From 22 to 31, I add 9. So I know for a fact that my d equals 9. My a sub n, that sub n there, is what term I'm trying to find. So it says the 12th term, so I'm going to rewrite this. A sub 12 equals, now a sub 1 is the first term in our sequence, which in this case is 4. 4 plus n minus 1, which n, again, is the term we're trying to find, so 12 minus 1 times 9. So again, we're going to now just solve this using basic algebra. So 4 plus 12 minus 1 is 11 times 9. So a sub 12 equals 4 plus 99. So my 12th term in this sequence should be 103. A sub 12 equals 103. Last but not least on this page, tickets to a dance cost $5 each. Decorations, food, and music cost $350. Find a function that describes this sequence and the total profit, then find the total profit if 93 tickets are sold. So first, we want to find a function. So we, again, know it should be y equals. Now, tickets cost $5 each. So $5, and then I'm just going to call x the number of tickets, since we don't know how many tickets, and that can vary. So it's 5 times however many tickets, so since we don't know that, now we're going to subtract, we're going to say minus 350, because decorations, food, and music will always cost that $350. So no matter how many tickets we sell, we still have to pay out of our pockets $350 to get the decorations, get the food, and pay for the music. So we found our function that describes this sequence. Now we want to find the total profit if we sold 93 tickets total. So I'm going to draw a little divider here and do a little math problem over here. And we're going to want it to be a complete sentence, complete thought at the end, since this is a word problem. So our function is y equals 5x minus 350. So I already named my x the number of tickets, so y equals 5 times 93 minus 350. So if I multiply 5 and 93 together, I end up getting 465, 465 minus 350. So y, which is the total profit, if we subtract $350 that we have to pay from the $465 we earned from selling all these tickets, we'd end up getting 115. So my final answer, again, should be complete sentence, complete thought. So we're going to write the total profit would be $115. So we sold $465 worth of tickets, but we had to pay $350 for the decorations, food, and music. So total, the amount of money we earned from this dance would be $115.